In this video we're going to look at how we form bonding and anti-bonding orbitals. We're first going to look at the overlap of a p orbital, in particular the pz orbital. You should remember from a previous video how to draw these. So here you can see that the opposite phases are facing each other. This we call out phase. This forms an anti-bonding orbital as we get a nodal plane perpendicular to the Z bond axis. This is because the electrons repel, making these lobes bigger and no bond is formed. This here is called in phase, as the same phases are facing each other. This creates a bonding orbital. As you can see, the orbitals overlap. We can call this one a sigma star antibonding orbital. This basically means that when we're on this Z bond axis, when we look up and down, we're in the same phase. The phase does not change along the axis. Same here, when we're on the Z bond axis, when we look up and down, we're in the same phase. So this is a sigma bonding orbital. Now we're going to look at bonding two px orbitals together. This you should realise is out phase and therefore is going to create an anti-bonding orbital. You can see that we've got the nodal plane perpendicular to the Z bond axis, so we also have a nodal plane through the nucleus. You can see here that repulsion has caused the lobes to stick over here instead of being straight up and down. Here you should recognise that this is in phase, and therefore we're going to get a bonding orbital. You can see that we have another nodal plane through the centre, but a bond has been formed above and below. Here we can say that we've formed a pi star bond, as if you sit on the X bond axis and you look above and below, the phases change. Same here, so this is just a pi bonding orbital. Well, now we're going to look at the S and PZ orbitals bonding together. You should recognise and be familiar that this is out phase and therefore creates an anti-bonding orbital. You can see that again we have a nodal plane perpendicular to the Z bond axis. Due to repulsion, the S orbital has been distorted, and so has the PZ orbital. This. If we look below, these you can see are in phase and therefore create a bonding orbital. You can see here that the S and P orbital have overlapped to form a molecular orbital. And going back to whether this is a sigma or pi bond, or if we're on the Z bond axis and we look above and below, there is no change in sign. Therefore, it's a sigma anti-bond and bonding orbital. Okay, so welcome back. Now these are just a few of the examples that will not form any sort of bond. So if you look at this S orbital and px orbital, you can see that this will not form a bonding or anti-bonding orbital, as half of this s orbital is happy as it's in phase, but the other half is not happy as it's out of phase. Same here with this pz orbital and the px, half of it's in phase, half of it's out of phase, therefore neither bonding or antibonding orbitals can form. And it's the exact same principle here with this d orbital and the pz orbital. So just remember that the orbitals need to have the same symmetry and the same phase to be able to form a bond. Okay, now question 1. Do you think these two d orbitals, they are dxz orbitals, will they form a bonding or antibonding orbital? Please select A or B.